Hello Cloud Gurus and welcome to this lesson where we're going to discuss a method of optimizing EC2 instance performance at the network level. We're going to be discussing EC2 placement groups. We'll look at the architecture of placement groups, the benefits they provide, and we'll look at how to use them operationally together with their limitations. So let's get started. So let's begin by answering the obvious question, what is a placement group? And the best way of answering this is to give you a visual overview of EC2, or more specifically, how EC2 is architecturally constructed with an emphasis on the networking side of things. Let's start off with an EC2 instance. And for now, the specific size and capabilities of this instance isn't relevant, though soon it will be. Now, you may have been exposed in your career to traditional server virtualization, products such as VMware, Hyper-V, and XenServer. And if you've experience of traditional virtualization, you'll know that architecturally, multiple virtual machines, or in this case, EC2 instances, can occupy a physical server. Now, with AWS, under normal circumstances, you don't have any visibility of these physical servers, but they do exist. And within AWS, we also have another physical construct that you have no visibility of, and that's a physical data center. And this is a physical entity that AWS manage behind the scenes, which you don't have any visibility of from within the console, CLI, or API. It's in this data center that the physical AWS servers are housed. And at a more granular level, within this data center will be the concept of a rack. And a rack is a group of servers and optionally some isolated networking components grouped together. Now, there are likely to be many of these racks within a single data center area, a module, or a data center floor. And there might be multiple floors within a single data center. And if you've watched the introductory AWS architecture lesson, you'll know that while you don't see data centers, you do see availability zones. And an availability zone, whilst being represented in AWS as a single logical entity, can in fact be physically constructed from one or more physical data centers. And these physical data centers will have within them multiple floors, multiple racks, and many physical servers. And to finish up this architecture, within a region, you'll have at least 2 availability zones. In some regions it's 3 or 4, and it depends entirely on the local needs of that region. Very simply, this is the compute architecture of an AWS region. Now, I know that I've omitted a number of important elements, such as storage, but for now, this isn't relevant. I want to concentrate on the networking, specifically the networking performance. So to explain placement group, let's first look at what happens when you launch an instance. By default, when launching an instance, you can specify a specific subnet and thus an availability to launch in. Or you can, in the case of the default VPC, specify no preference, and this gives AWS free rein to perform capacity management and assign an instance to any of the free availability zones. So the first time you launch an instance, it might be within one rack, the next could be in a completely different availability zone, or in the same availability zone but in a different physical data center, or it could be in another floor in another AZ, a completely separate compute facility. Now, equally, you could launch 4 instances, and through sheer luck, all 4 could be launched on one physical server. What I want to illustrate is that it's random, or rather semi-random by default. Unless you direct otherwise, you're giving AWS the ability to position your instances within any physical server, in any physical data center, in any availability zone. And you have the option to specify an availability zone and a specific subnet to limit that down. Now, before we look at placement groups, I want to introduce 3 concepts. The first seems logical, but it's worth saying anyway. I could launch a huge instance which would take up all of the available capacity on a physical server. Or alternatively, I could launch 100 smaller instances which might use the same physical capacity as the single huge server. AWS handles the positioning of those instances on physical machines based on their capacity and performance management systems. Now, different EC2 instances have different performance characteristics. We'll go into detail on this in a separate lesson, but be aware that the performance of an M4.large might be fairly modest. You have a maximum bandwidth of 450 megabits per second, and you can expect to push around 56 megabytes a second maximum through that instance. With a large instance though, for example an X132XL, these maximums are much higher. With this size, you're connected with a 10,000 megabits per second connection, so a 10 gig connection, and this can achieve a peak throughput of 1250 megabytes a second. It's important to conceptually understand that these are maximums and ideal throughput rates. They depend heavily on the underlying infrastructure to provide this level of connectivity. Let's look at this underlying connectivity on the next slide. It's important to realise that the supporting infrastructure matters. When you have a slower instance, this influence is less pronounced, but to achieve 1250 megabytes a second between two instances, you need a good quality, stable chain of supporting technologies to allow this. Now, the first is obvious, we've just talked about it. You need to provision large instances which are capable of delivering the bandwidth that you need. And you also need to ensure that enhanced networking is enabled. And I'll delve more into this in a dedicated lesson. For now, just be aware that advanced networking is a feature that needs to be present to allow the faster and more consistent network performance between instances. Now, what you might now start to realise is that the physical location of instances actually matters when you're looking at the higher tiers of performance requirements. With the architecture on screen now, consider that you have a number of different zones or points of data transfer. First, you have the zone between instances on the same physical machine. And traffic between instances is internal to a machine. It doesn't actually touch the physical network at all in most virtualization platforms. Next, you have the transfer between instances on different physical servers in the same rack. And this does use the physical networking, but potentially it might use networking located within the rack, for example, a rack-based local high-speed switch. Following on from this, you have data transfer between instances running on physical servers in different racks. And potentially this will be slower as it has to cross rack distribution networking, but this is likely to be fibre and it will be running at a fairly good bitrate. The same is true for transit between areas, modules and floors, which is likely also to be fibre running across local distribution networking equipment. But it's at this point that we start to slow down slightly and we add some latency. When we're talking about transit between physical facilities which make up an availability zone, we do have to contend with geography. AWS tried to make the logical AZ construct transparent and provide fast physical connectivity, but still there is always added latency between separate physical locations, and for some types of compute this matters. Now, AWS do guarantee the performance between these physical locations, so data transit inside an availability zone does have performance targets, so just keep this in mind. But we also have transits between availability zones, and this will have added latency and will potentially be slower and more contended. AWS do make best efforts to provide good, reliable inter-AZ transit, but it's not as good as the types which I've spoke about before. Remember, transit between availability zones could be traversing a metro area or sometimes even a state area. AZs are always physically separated, and even AWS can't break the laws of physics. Whenever you're transferring data across large distances, you are going to have data latency issues. You may be able to maintain the data throughput rate via good quality high bitrate fiber, but you do always have additional latency when you're covering greater distances. Now, each step in this progression, from instances on the same physical machine to instances in different availability zones, gets potentially slower and adds additional latency. Both of these matter for demanding compute applications. I'm going to keep mentioning this. For high-performance computing, throughput and data latency and the consistency of that data latency are very important. So let's talk now about how a placement group works, its benefits and its limitations. So what is a placement group? It's a logical construct that you create within the EC2 console, the CLI or the API. It doesn't cost anything to make, and when you initially make it, it doesn't actually do anything but signal your intention to AWS to prepare for the next step. After you've made a placement group, this is where the magic happens. You launch instances into that placement group. Let's say you wanted to launch 6 instances. What would happen is that you would signal to AWS your desire to do so. And AWS would look at the number of instances you want to provision and identify a section of their infrastructure with the capacity to host these instances. Its aim would be to find machines in a physically close group of compute hosts. And into this, it would launch the instances that you requested. Now, you can remove instances in the normal way by terminating them. And you can add more machines into an existing placement group, but only up to the capacity of the placement group. Remember, because this is physical, AWS may, for example, allocate you space in a placement group for 6 instances. Now, in the back end, it can actually cope with 10 instances, but if you launch 6 and then attempt 6 more, the second set will fail to launch. It's always recommended that you launch all of the instances you want to have in a placement group at the same time when you do the initial launch of any instances into that placement group. Doing so allows AWS to pick a physical location which has enough capacity for all of the instances you want to launch, rather than picking one which doesn't have sufficient capacity that risks you running out of space for your placement group when you try to launch additional instances later. Now, instances launched into a placement group benefit from the close physical proximity, so they benefit from low latency. And they're also able to achieve the 10 plus gig network speeds that the larger instances can provide, rather than the 5 gigabit speeds that instance-to-instance communication is limited to when communicating with machines outside a placement group. This is a key thing to understand. The top-end speeds and the consistent low latency that EC2 is able to provide and that high-performance compute applications need is reliant on a few things. Firstly, the size and type of the instances you're launching. Secondly, the presence of the enhanced networking feature. And finally, the use of a placement group. It's the placement group that guarantees the performance between instances because it guarantees a local proximity that random instant placement cannot. Let's move on to the next slide and look at some limitations or requirements of placement groups. And these are critical to know for the exam. Firstly, from an exam perspective, and this is the big one, placement groups cannot span multiple availability zones. When you create a placement group, you don't actually pick an availability zone. But when you first create an instance and pick a placement group, the placement group is allocated to the AZ that you launch that instance in. So in this case, US East 1A. If we tried to launch an instance in another availability group, so in this case we tried to launch one in 1B and the same placement group, then we'd receive an error. We're told that the placement group ACG test is in use in another availability zone. So this is critical. You create a placement group without allocating it to an availability zone. But once you launch the first instance into that placement group, the placement group is tagged to the availability zone that you launch the instance in. And from that point onwards, you need to use the same one. You cannot span availability zones with placement groups. I need to stress this because it's crucial to know for the exam. You will be tested on your knowledge of this point. Now also know that the name of a placement group is unique. It's unique across all regions in your account. Keep this in mind when you decide upon a naming scheme, and do remember it for the exam. You cannot have a placement group with the same name as another placement group, even if they're in separate regions. And this is slightly different than most AWS products, which are region scoped for their name. Now, not all instance types are supported for use within placement groups. For example, the T2 instance classes aren't. I'll put a link on your screen to the current list of what instance types are supported. But be aware generally that it's the dedicated higher performance instances which are supported by placement groups, the ones which may be used, for example, with high performance computing. It's the ones where it's clear that it'll be beneficial to launch them within a placement group. So any of the instances which are capable of high throughput are candidates for launching in a placement group. Now, related to this, you should, where possible, stick to the same type and size of instances within a single placement group. While mixing is supported, it increases the likelihood that you will have placement group capacity issues and won't be able to launch additional instances into an existing group. Also be aware that you can't move existing instances into placement groups. As a workaround, you'll need to create an AMI from an existing instance and then create a new instance from this AMI in that placement group. And likewise, you can't merge placement groups. You need to terminate all instances in the placement groups that you want to join, optionally create AMIs to back up, and then create a new placement group with all of those instances inside. Traffic to and from external services, so services outside the placement group, is limited to 5 gigabits per second. So anything outside the placement group is slower than instance-to-instance communication inside the placement group. And this is the case no matter what the performance provided by the external or internal instances. If you're doing communications to or from external services, it's limited to 5 gigabits per second. And relating to this, always ensure that machines are communicating within the placement group using the private IPv4 or IPv6 addresses. If you're using public addressing, it will seem to AWS that you're communicating with machines outside of the placement group, and your rate of communications is going to be limited. As previously mentioned, ideally always launch all of the instances that you're ever going to have in the placement group at the start. When you do so, it provides AWS with the capacity information to pick a suitable physical location to host your instances, and so you're not going to run out of capacity. And lastly, this is important to know for the exam, placement groups can work over VPC peers, but there is a speed limitation. So while factually you can use them, perhaps operationally you wouldn't use them in production if you're going to cross the VPC boundaries. Okay, so that's the end of the theory lesson on placement groups. I hope it's been useful, and be sure that you fully understand all of the benefits, the restrictions, and the architecture. All 3 of those elements are essential for the exam. You will get at least one question about placement groups. And feedback from other students is that you'll actually get multiples. If not directly questioned about placement groups, you'll have questions which indirectly require the knowledge that you've gained in this lesson. So make sure that you understand all of the concepts, and if you do need to watch it again, then please do so. If you do have any questions about this lesson or any of the others, please reach out directly or via the Cloud Guru forums. Otherwise, feel free to complete this lesson and move on to the next.